Hello, my name is Chris Harding, and this tutorial is going to cover the creation of full cylinder from the half a cylinder that you see here. This time I'm going to keep the points the same, and I'm just going to mirror each each set of points going in the negative y direction, so we'll end up with a full cylinder. As you can see, there's block 1, block 2, block 3, block 4, block 5, block 6, block 7, block 8, block 9, and block 10. There's 10 hex blocks. So when we're finished, we're going to have 20 hex blocks, and we're going to have, I believe there's 16 arcs. There's 1, 2, 3, 4, 5, 6, 7, 8, and then 8 in the z direction repeated for that side, that plane. And so there's 16 arcs, and we're going to end up having 32 arcs. So because it's going to be mirrored down in this direction. So we're going to have to build those up, and we're going to have to specify the block meshes and the arcs properly. But really, the arcs we can just copy and paste, because the only difference is going to be the x-axis is the same, z-axis is the same. The only thing that's going to change is the y-axis. So, so we can actually copy and paste and then make the y-axis negative all throughout, and that'll give us the same points. So it's not a lot of points to enter in or mathematics to do. Um, so you can see here that this is from the last tutorial, and I started out wanting with the desire to learn how to build a full cylinder. And I started out with part 1 in the pointField.H series. For me, is part 1 is working with doing pointField.H programming along with cavity tutorial, grow it from 4 points, mirror it, and 2 points, grow y, and then mirror it, and playing around with programming like that. So what I'm going to do now is I get pretty good with that, and I get pretty good with hex block specification and boundary face specification, especially after doing the rectangle and the half cylinder. Um, I got really good with specifying those. I got a pretty good method going down. As you can see here, the number on the left is 0 and the number on the right is 19. And 0 is left, that's back, 19's front, and that's the front plane after we grow z out by +2 and 2 centimeters. And the radius is 1 centimeter, so the diameter of this circular cylinder is going to be 2 centimeters. And so if we go to what I did originally, is I went to the tutorial for the cylinder, because it has pointField.H in there, and it also develops a cylinder, half cylinder with geometry that's not really like this. It's cut off, but you can make it more custom, and you can use the same settings for symmetry for the upper wall, symmetry for the bottom wall, and I'm using no slip wall condition for the cylinder. And so, but some people use symmetry for the cylinder, circular cylinder, and I'm just using no slip. I saw that in another person's desire or development, and I don't know if symmetry does the same thing. I'm not 100% sure about what symmetry does. I know that it affects it, it it can affect the, well, it affects the geometry and the meshing, and so it has an effect on each of those, and but I'm not exactly sure what the effect is. So let me see here. what do we have? So that come from the tutorial, and then after I copied that from the tutorial, I did my cylinder for my block mesh, and for the and I forgot to convert to centimeters here. So we'll do that now. So, and this could have kept it meters, but converted centimeters. Millimeters would be 0.001. And you can see here that what I did was I did nothing more than just change the actual distance or the points on the one that I got from the tutorial, and I put in the info for the number of points. I like to see my points printed out because a lot of times I won't have access to the geometry, and if I want to see if the points make sense, because a lot of times when you run block mesh, a person can get an error that there's a problem with the hex block and some boundary faces inward pointing as an example, and that might have nothing to do with the hex block. It could literally have something to do with the actual points that a person is putting in. They're way off. For example, instead of 9, put in 99 when everything else is around 9 or 8 or 3 or 0. And it can cause an error, and because it just doesn't seem logical, and it can cause geometry to get misconfigured, and then it can give an error, and it's hard to find that error. So I like to print out my points, so that's what I put in here. And then you can see there's 10 hex blocks here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hex blocks here, and then numbered over here. And there's a total of 16 arcs. And I described that a little bit when we were looking at this document over here. And then the faces, I'm keeping all these. And what I'm going to do is the faces I'm keeping, the one, except for example, the bottom wall. The bottom wall is going to change. I'm deleting those, and I'll have to put in my own bottom wall because we're duplicating this. And this bottom wall right here will no longer exist. We don't even want a wall here. We want mesh. We want this to be meshed, but we're going to skip these 6 points programmatically, and and so the bottom wall is going to be, after we flip it, is going to be a symmetry of the top wall, but we're going to build the bottom wall ourselves. But we're going to keep all these other faces, and then what we're going to do is add to them. And I've already done this because it would be complicated to try to go through all this in a live tutorial, because errors are made and debugging. I don't think everybody wants to go through and learn all that. It's just something a person has to get used to on their own. There are some things that seem to some rhyme and reason to block mesh dictionary debugging, but I'm not perfect at it, that's for sure. I wish I was. And but anyways, I do fine, and I was capable of doing this full cylinder. And as you can see here, this is the for the full cylinder. I keep the same 19 points at the beginning, and this time, instead of mirroring the points and getting different points, having to redraw this and getting different points like I did with the square, I kept these points and then I mirrored them after Z was duplicated. So what I did was I kept Z here. It mirrors these points into Z, so it creates this geometry right here. And this is 3D. The left is back and the right is front. And so it creates this right here with this part from here to here. And then my code, after that, what I do is I say my, which is mirror y. I create a new label, my point size, so it's going to be total size of 38, because the new point size is going to be 2 times SZ, and SZ is 19, so it's going to be 38. So my is equal to 38, and the new point size is we're going to duplicate both planes in the negative y direction that we have right now, two planes in negative y direction. So that's going to be 2 times my. So that's going to be a total of 38 and 38 is 1674. So it's going to be a total of 74 points, but we're going to miss 6 point, or not just 6, 12 points in the center, because we don't have to duplicate the center. So we don't have to duplicate to 0, and it's already made. So we don't have to duplicate to 0, 19, 1, 20, or any of those points in the center line. So we're going to subtract those. So how I did that is I said, well, first what I want to do is start out 6, because to go to my next picture, which is my point map for the full cylinder, you can see that we want to mirror 6, 7, 8, 9, and 10, and we want to mirror it. We don't want to mirror the center. We want to mirror starting at point 6, and we want to mirror continuing until point 18. So we're going to mirror that plane first, the back plane, in the negative y direction. So we're going to start out at 6, and we're going to be less than my, which is 38, and we're going to go I++. This is the for loop for all of it, and then we have 2 if statements in here. And I've noticed with OpenFoam, they're liberal of using if more often than if and else if, it seems. And so hopefully I'm doing this correctly here. And I noticed I had problems when I tried to use else if and else. Not else if, but else. But else if worked fine. But I used 2 if statements here. And I said when I is from 6 to 19, so when I is from 6 to less than 19, less than 19, so that's 18, which is right here, because it goes 15, we go 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So from 6 to 18 here, we're going to mirror that. So I less than 18. This mirrors one plane, and we say we mirror it in the negative y direction. It's just simple. But I take off 6, my 38 minus 6, because 1, I want to start out at 38, because when you continue on with the numbering and you do the Z and then you start out the new direction, it starts out with 38. So I want the mirrored line to start out with the number 38. So I go down here and I don't need the 6 points in the center, so I subtract 6 from 38, and that's 32. And 6 plus 32 is 38, and that's the first point. And it's going to go 39, 40, 41, 42, 43, and it's going to go until I is 18. And then at I at 18, it's going to switch, and I less than 18 is going to switch. And then I say if I is for the next plane 24, because if you look, here's the first 6 points is for the Z is 19, 20, 21, 22, 23, 24. And so I want I greater than 24, so at 25, because we're going to mirror the front plane now in the negative y direction. And I is 24, and it's less than 38, which is 37 right here. We're going to mirror that in this direction. And so all we have is a negative y here, but we need 26 points, and because we're moving a total of 12 points, so we got I plus 26, and it gives us our points that correlate to what this point map looks like. And then of course after I do that, I printed out the points, and when I first did this, I had problems with my points. My if statements were not quite right. Had problems with my points, so it's a good idea to print out points when you're playing around with pointField.H. In my opinion, it's a good idea to print out points so you can check, because it'll give you errors that hex blocks are having problems, and the problems will be in the actual point generation itself, not the programming necessarily. It'll work fine, but if you don't program right, it's going to give the wrong points, and that happened to me. So just thought I would mention that. So you can see this what we did, and I specified 10 more hex blocks. I kept the hex blocks that we had from the other one. I just mirrored, I just foam cloned the case and then kept those. And then, which reminds me, gotta change this one to 0.01 too, because I want it in centimeters. Thought that there was, okay. And then I created the other hex blocks that I needed, which are which would be this one: 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And that's these hex blocks right here. And I created those hex blocks. And then for the arcs, for the bottom, for the below geometry, I just copied these arcs, copied, pasted that here, and then I changed the points for the arc locations, because, for example, we go from 1 to 39 here, and it's 1 to 39 here, but it's going to be the same numbers as for this right here. It's just going to be negative y. X and z is going to be the same, so you just have to go down and put a negative for all the y's. You can do the same thing for this. You just have to change the arc points from where to where. The interpolation points, you just have to change the negative y coordinate, or from a positive y coordinate to a negative y coordinate. So that's pretty easy to do. And then I specified the faces and the blocks, or I specified the faces. And the way a hex block is created is, I'll do this first one here, is this is 0. If the manual says that you're supposed to take the origin, for me it's 0, um, and you're supposed to put that closest to you. Right now this is back, remember, left is back, so this is, if I lifted the paper forward to us, 0 would stay in the back, and however far I lift it would be the z direction. And you're supposed to take that whole quantity, that whole two-dimensional quantity, and flip it and put the origin closest to your eye, and then actually go clockwise in the direction of what the points are for the blocks, to specify in the hex notation in the block mesh dictionary. And so the thing is, instead of doing it that way, you can keep it as written on paper, and then I know that the opposite of clockwise is counterclockwise if I don't flip it. So if I flip it and go clockwise, it's the same as not flipping it and going counterclockwise. So 0, 38, 39, 1, 0, 38, 39, 1, 19, 51, 52, 20. 19, 51, 52, 20. And that's how you do all the blocks. And it's just repetition. But if you want to watch it again, you can go back and watch that again. But that's how you do the blocks. I'm not going to go over all the blocks. But a face, let's say you want to do inlet, because you want to add to the inlet, where he had these two values up here added to the this face right here, from here to here, and the face from here to here, where he had those added. So we just need to add this face right here and then this face right here. Face is a little more difficult to see on two-dimensional paper, because you have to look from the inside of the block out, and then you go clockwise direction on the face, that you run into. So if you're walking from the inside out and you're walking through a door frame, for example, that's the face. And you got to look at the bottom left, the top left, top right, and bottom right in order to get clockwise direction. But we're looking at this from a front of a paper. So that's the reason why I like the left and the right. And the left is back, the right is front. And if we want to go clockwise, we have to go from the smallest number, we have to go, um, if we went 0 from the back to 19 to the front, then that wouldn't be. So we want to go with 0, 38, 51, 19 is clockwise. If you go from 0 to 19 and you're going through this block, this face right here rather, then that would be counterclockwise. 0, 38 going down and then forward to 51 and then up to 19 is actually clockwise direction. So 0, 38, 51, 19, because we want to look from inside the block out, or if you're walking through, it's like a door frame. If it's an inlet, it's open. If it's a wall, then you run into a door there. You run into a wall, and you can't go through it. And so, I mean, I know this is simple, but little things like that help me get through. And because it's alien, everything's so new. So having little things, it's just that's the best way for me to learn, and it's helped me learn OpenFoam. And but I'm far from an expert, and I'm just a beginner helping beginners. So just like our Facebook group, Beginning OpenFoam. And let me see here. So that's face. And so we're going to do 0, 38, 51, 19, 0, 38, 51, 19, and then 38, 43, 56, 51. So, and then 38, 43, 56, 51. And then I'll do this face right here, because it's going to be added on. And 2 and 21 is this point. The left is the back plane, and the right is the front plane. So it's after we grow Z out. But so we got, if we're looking at this and we're going from inside and going out, if we walked, we'd be going this direction and we hit it, then we want to go clockwise before we hit it. And we want to go clockwise at the points. And there's only 4 points, so we want to go clockwise with the points. And 2 is in the back, 21 is in the front. I like starting out with the smaller numbers. Makes it a little more challenging sometimes, but it keeps me organized. And so for the cylinder, you got 2, 21, 61, 48. 2, 21, because if we go from front to forward and then down and then back, we're going clockwise. So it's 2, 21, 61, 48. And then you do the rest of them like that. So you're looking in and out, and think of this as the back, 48's back, 21's front, 61's front. And if you go from 2 to 48, for example, then go forward, that's going to be counterclockwise. So you want to go in the opposite direction, 2, 21, 61, 48. It's just very tedious and a lot of work. And I went ahead and kept what type or what faces I had before, and then I used the default faces setting where I put my P and my U, default faces, so where I don't mention the rest of the faces, and they're automatically generated as empty. And so I used both. I did what was already included I included for the half cylinder, just so because I was practicing faces and things of that nature. So, but I included them, and this time I used a feature in OpenFoam that will automatically specify what you don't specify as a face. It'll automatically specify those faces that need to be specified as empty. And for example, around the front wall and the back wall, and then specify those as empty. So I didn't specify the lower half, and it should have worked. I wanted to see if it would work, and it did work. So that's what I did. And so now, so you can see we're in point field and full cylinder. So let me go ahead and do foam clean tutorials. I'm a horrible typist and speller. And foam clean polymesh. My hands shake, so I have a hard time sometimes. Part of my illness. I'm a 100% disabled veteran. I'm a chemical engineer by training, but I have other illnesses that affect me. But I'm just fine. So don't worry yourself. But let's see here. So let's go ahead. I foam clean polymesh. Let's block mesh. And then let's take a look at the mesh. So there's our cylinder. It's circular. If our arcs wasn't working, one of these would be straight. It's circular in this direction, and it's circular in this direction. And so this is the actual back wall. This is where 0 and the numbers are. This is the front wall. Uh, this half up here was mirrored to create this bottom half programmatically, and it worked. And so let's go ahead and go to solid color and then go to surface with edges. And this is an optimized mesh. I'm going to have to work with that. I'm going to have to go to that route next. But I know that the well-known Thomas Tian, who does CFD and is very well known in CFD arena, he actually he reminded me because he saw my mesh. I think he thought it was my finished mesh, and he was like, "Oh my God!" Well, I don't know what he said, but he wanted to remind me that the coarse mesh should not be 20% or greater than the refined mesh. So 20% greater than the fine mesh when you go from fine mesh to coarse mesh. But I'm using these just to show the coarseness of them. One, because I haven't optimized meshes yet, which I'm going to be doing a little bit with this. I'm going to use that principle that he taught me, and then I'm going to use some grading tools. But two is I'm I want two I wanted to show what or where the lines are supposed to meet up and things of that nature. It's much easier to see when it's not graded because they're not so dark. You don't have to zoom in. And it just shows you nice and clearly with about 10 of them where they meet up and everything. So it's more for tutorial purposes. But that's the mesh. As you can see, it's meshed on both sides. And let's go ahead and close out this. And let's do a parafoam block. Well, that's not good. It's not giving me a view of the block. Something wrong with Paraphone. Um, for some reason, it's starting to fail me. But sorry to include that in my tutorial, but this is live, and it's something that I forgot when I did this last Friday, that Paraphone block wasn't working for me on this one. So that sometimes happens, but I guess it happens to me anyways. But now, anyways, so I'm finished with this tutorial. I hope you learned something. I hope that I'll go over here and I'll go ahead and scroll down in case people just want to put in the actual points and don't want to and just copy it. So I'll say pause, 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 pause. You have a nice day. If you like the video, like it. If you have a comment, please comment. And you have a nice day.